We talked about integration earlier in yesterday's class, and today we are going to see some common integrations and some common integration techniques we are going to see that we might encounter in physics. Okay, so in physics we don't need lot of maths, but we need some maths. Okay, so that's what we are going to cover today. Some integration techniques which we might need. All right, so let's begin. So first of them is integration by substitution. Okay, so for an example, if we have integrals of this kind of form, okay, oh, sorry. So let's say we have integration of this kind of a form, okay, integral of a form where we have integral of some function of a polynomial, okay, ax plus b, let's say. Then what we do is, so this would be derivative of some other function, okay, so this is f of ax plus b, right? So let's suppose the small f of x is derivative of capital F of x, okay. So suppose that if we take derivative of some capital F of x, some function, then what do we get? We get the small f of x, okay. So if we integrate this one, small f of x, we'll get what? We'll get the capital F of x, right? So if derivative of this function is this function, then integration of this second function would be the first function. This much we know, right? So here we don't have f of x, we have f of ax plus b, okay. So what we do here is we put ax plus b equals to some other variable, variable, let us call it t, okay. So let's call it t. So we substitute ax plus b equals to t. Now if you take derivative on both the sides, what do you get? On left hand side you will get what? A only,
Yes.
right? If you take d by dx on both sides, so here it's ax plus b, on right hand side it's t, so you get dt by dx. And then on left hand side you will get a, so derivative of x with x is 1, so you get a here, derivative of b is 0, okay. So you get a, and then you can take this dx on left hand side, okay. So you write it in differential form, you can write dx on left hand side, so you get dt on right hand side, right? So see, now we have substituted that ax plus b is equal to t. Then if we take derivative, okay, if we take derivative of this, what do we get? We get a on left hand side, and on right hand side what do we get? We get dt by dx. Now I will take dx on the left hand side, so what do I get? I get dt, okay. So now this dx can be written as, how can I write this dx? So I can take this a on other side, okay, so it will be dt upon a, okay. So dx can be written as dt divided by a. And now if I substitute this thing over here, and in place of ax plus b if I write t, what do I get? The integration changes to f of t dt divided by a, right?
Yes, sir.
Okay. So then what is f of t dt? So see, f of x dx, integration of f of x dx is capital F of x, okay. So it is capital F of x plus some constant, because this is indefinite integral, okay. So now I will take this a outside, it is just integral of f of t dt. Now it doesn't matter whether we have x here or we have some other variable. The relation between this function and this function is that if you take derivative of this function, you will get this function, okay. So if you integrate this function, you will get back this function, right? So I will integrate it. So this is going to be equal to 1 upon a multiplied by f of t, because we have t over here. Okay, 1 upon a I have taken out. The integral of this small f of t dt is capital F of t, and plus we have the integration constant. And then after doing all this, we can substitute ax plus b back in place of t. Okay, so I can write
Yes,
this
sir.
as f of capital F of ax plus b divided by a plus c. Okay, so is it clear?
Yes, sir.
Clear to
Yes, sir.
everybody?
Sure.
Okay, good. So now see, this is the method, but now what we can do is we can directly integrate this if we know the relation between this function and this function. Okay, so we can directly integrate this. So we will just write it is integration of this small f is equal to what? It is capital F. Whatever is there inside the bracket, we'll write it as it is. Okay, so we'll write capital F of ax plus b, and then we'll divide. Okay, we'll divide by the derivative of the term inside the bracket. Okay, if you like, you can follow this part, you
Okay,
can do
sir.
all of this. Okay, but there is no need to do all of this. What you can do is just see the relation between these functions. You have small f and capital F. Okay, so derivative of capital F is small f, right? So if you integrate small f, you will get capital F. So the small f inside this integration, okay, integration sign, so this thing is known as integrand. Okay, so small f is function of this thing, so you will write its integral, which is capital F, as function of same thing, okay, which is there inside the bracket, and then you will divide it by what? You will divide it by the derivative of bracket. Okay, that's a shortcut. No need to do all of this.
Okay, sir.
Correct?
Okay, sir.
Yeah. So yes. So now see, in derivatives, what do we do? If we have chain rule, okay, if I have chain rule, then if I take derivative of this, what is it? So I will take derivative of this function. Okay, so derivative of f, capital F is small f, then I multiply by what? I multiply by derivative of the term in the bracket. Okay, so we have done that day before yesterday, right? So in
Yes, sir.
integration we divide. Okay, in integration we divide by term in the bracket. We do the reverse procedure. This is the chain rule. Okay, applied inversely, right? Okay, so let's see examples so that you will understand it. Okay, so first example now. So who can tell me the answer? What is integral of cos x? Okay, so what should we do here? This is cos of 7x plus 9. So I can substitute t in place of 7x plus 9, right? I can do that. Okay, so I can put t equals to, let t equals to 7x plus 9. Now if I take derivative of this, what do I get? dt by dx equals to 7. So I can write, if I take dx on this side and 7 on the other side, I can write dx as dt by 7. Okay, so I will put dt by 7 in place of dx, and t equals to what? 7x plus 9. Then what do I get? Doing this substitution, I get cos of t dt by 7, and that 1 by 7 I can take out. Okay, I can take it outside of the integral because it's just a number. So this is equal to 1 by 7 multiplied by, what is integral of cos t?
Sin t.
Sin t. Okay, so it is integral of sin t, but since we are doing indefinite integral, a constant will come in. Okay, and then what's our t? It is 7x plus 9. Okay, so we can substitute that. So it will be sine of 7x plus 9, okay, divided by 7. So it is sine of 7x plus 9 divided by 7 plus c. Understood?
Yes, sir.
Yes, sir.
Okay, so this is by doing substitution, right? So instead of doing all of this, what I'm saying is, just take this thing, it is cos of something. Okay, it is cos of something. So what will be its integral? It will be sine of something, not something, sine of that thing only. Okay, so this is cos of something, then its integral is sine of that thing. Okay, so I will write it here. So I am taking integration of cos of 7x plus 9 dt. So it is sine of 7x plus 9, okay, and plus some constant because we are doing indefinite integral. Okay, but now see, I don't have x here. Oh, I'm sorry, it's integral of this thing dx, not dt. Then see, I am taking integration of this thing, cos of this thing. It will be sine of that thing divided by what? The derivative of the term inside the bracket. And what's that? What is derivative of 7x plus 9?
7.
7.
7. Okay. So I will put 7 here. So instead of doing all of these steps, we can do it in one step only. Right? Monali, you got it?
Yes, sir.
Yes, no, Monali? Are you there, Monali?
Yes, sir.
Okay. You got this or not?
Yes, sir.
Okay.
I got this. Sir.
Okay. So now tell me this one. Okay. So earlier problem, we had cos, now we have sine. So tell me directly, what will be integral of this? So integration of sine is cos or minus cos?
Minus cos.
Minus cos. Okay. So it is minus cos minus cosine of this thing. Okay. So integration of sine is minus cos. 5x plus 8, and there will be an integration constant. And since I don't have x here, I have something, some function of x inside the bracket. I will divide by derivative of that function. So what is the function inside the bracket? It is 5x plus 8. What is derivative of that?
5.
5.
5.
Okay. So simple. No need to substitute t and do all of that. Actually, we are doing all of that, but inside our mind. Okay. Next. So here I have 4x plus 9 square. So what will be integral of this?
4x plus 9 the whole cube divided
Correct.
by 3 into
Yeah.
4.
Okay. So see, if I have integral of x dx, sorry, x raised to n dx, that integral is x raised to n plus 1 divided by n plus 1. So I will imagine, so this thing is x only. Okay. Or I will just take that bracket. I have bracket raised to something. So what I will do is, its integral will be back that bracket raised to n plus 1 divided by n plus 1. Right. So I am applying this formula as it is. Okay. So the integral is 4x plus 9 bracket raised to 2 plus 1, because I have this bracket raised to 2 over here. So 2 plus 1, which is 3, divided by 3. Okay, plus some constant, but inside the bracket I don't have x, I have some function of x. So what I have to do is I have to divide by derivative of that function, and that is, what is derivative of 4x plus 9?
4.
4. Okay, so it is 4, right? Very simple. Got it?
Yes, sir.
Okay, one more problem. So I have this integral 1 upon 3x minus 7. So what will be integral of this? Okay, so do you have some function whose derivative is 1 by x?
Log x.
Right. So see, I gave you the formula sheet. Okay, all of those formulae have to be memorized. So derivative of log x is 1 upon x. Therefore, integral of 1 upon x will be log of x. Okay, so again, let's put a bracket over here. It is 1 upon bracket. Okay, integral of that thing will be log of the bracket, right? So it is log of the bracket, log of 3x minus 7 divided by, so see, I have some function of x, I have to take its derivative, divided by what?
3.
3.
3.
Okay, and since I am doing indefinite integral, a constant will be there. Okay, so simple to apply this method, right?
Yes, sir.
Yes, sir.
Okay, so then next again we are doing the same thing. Again we'll do integration by substitution, but now we have to do the substitution. Okay, so now we can come across these kind of integrals. So first I have function of some other function. So this kind of function is known as composite function. Then in multiplication of that, I have derivative of this function. Okay, so I have function of g. I don't have function of x. I have function of g, which is some other function of x. Okay, and I also have its derivative. Right, I also have its derivative. Then what I will do is I will put, in place of g of x, I will put t. Okay, so suppose g of x is equal to t, right? So the substitution here will be g of x is equal to t, and then if you take its derivative, if you take the derivative, then derivative can be represented as g prime x, it's equal to dt by dx, right? And then if you take the dx on the left hand side, what do you get? You get g prime x dt, g prime x dx equals to dt. So g prime x dx equals to dt. So when we substitute g of x equals to t, then this g prime x dx becomes what? Dt. So this integral gets reduced to what? F of t, and this thing becomes dt. F of t dt, right?
Yes, sir.
Yes, sir.
Okay. Then it's assumed that I know the integral of that function, small f, which is capital F. Okay. Then I may have a function raised to n. Okay, a function raised to n, and it is accompanied by its derivative, right? So here also what I will do is I will substitute f of x equals to t, and then f dash x dx will become what? Dt, right? So here this integral will become if I substitute f of x equals to t, this integral gets reduced to what? F of t raised to n, sorry, f of t dt. No. What I am saying, I will write f of x as what? T. So it will be t raised to n. Okay, it will be t raised to n dt. Sorry. Okay, this is clear?
Yes, sir.
Yes, sir.
Okay. And then here also I will write f of x equals to t. So this is simple. Then f dash x dx is dt. So this integral gets reduced to what? This one gets reduced to dt by t. And whose integral is very simple. What? It's log of t. Log of t plus c. Okay. So any question in this?
No, sir.
Okay. So let's solve the problems. Okay, let's solve the problems. So next question is, I have x raised to 2 plus 8 raised to 3 and it's multiplied with 2x dx. Okay, so I have 2x dx. So what should I do? I should put this thing equals to t, because if I take derivative of x raised to 2, it is 2x. Okay, so sometimes this 2 will be there, sometimes 2 will not be there, some other number will be there. So at that time we have to adjust. Okay, so let's suppose there is 5. So what I will do is I will multiply by 2 and divide by 2. Okay, so let's suppose there is 5x. So what should I do? I will multiply by 2, divide by 2. I will take 5 by 2 outside. Okay,
Okay, sir.
all right. So let's solve this. So what do I get? Integral of this thing. So this will be some t raised to 3. Okay, dt. Clear? What I'm doing
Yes,
is
sir.
I'm substituting. So I'm saying let x raised to 2 plus 8. Okay, I don't have to put the bracket. X raised to 2 plus 8 is equal to t. So if I take its derivative, what do I get? On this side I will get 2x, and on the other side I will get dt by dx. And if I write it in the differential form, then I can take this dx, write it on left hand side. Okay, so 2x dx will become dt. So x raised to 2 plus 8 is t. So here I will substitute t, and 2x dx then becomes dt, right? So t raised to 3, okay, x raised to 2 plus 8 is t, and I have to the power 3, so it's t raised to 3 dt. Simple. So what is its
Yes,
integral?
Yes,
sir.
sir.
X raised to, sorry, t raised to,
T power 4 by 4.
yeah, t to the power 4 by 4 plus a constant. Okay, and then I will substitute back t. So what is t? X raised to 2 plus 8. So let's substitute that back. So it is x raised to 2 plus 8 to the power 4 divided by 4 plus c. Simple. Okay, no question, right?
No question, sir.
Okay, so what about this? Okay, I have written it in a manner that it will be easy to understand. Okay, right? So it is this function, this polynomial to the power 3, and I have derivative of this polynomial sitting in the multiplication. Okay, so what I will do is I will just write this as t, and this thing will be then dt. Okay, so let x raised to 3 plus 3x square plus 9 is t. So if I take its derivative will be x raised to 3's derivative is 3x square plus it is 3 times derivative of x square, which will be 2x. So it is 3 times 2x, and derivative of 9 is 0. Okay, derivative of 9 is 0 because it's a constant, and derivative of t with respect to x is dt by dx, and then I will take dx on the left side. So it is 3x square plus 6x dx equals to dt. Okay, and I will substitute that here. So this term becomes dt. This is my t raised to 3. So let's do that. So it is t raised to 3 dt. So answer is again t to the power 4,
T power 4
4
by 4.
divided by 4 plus c. Okay, and then we'll substitute back the value of t, which is x cube plus 3x square plus 9. So let's substitute that. So we get x cube plus 3x square plus 9 raised to 4 divided by 4 plus c. Okay, so very simple. This one, cot x dx. Anybody can say, what should we do? I want to integrate this cot x dx. I know the derivative of cot x. What is that, by the way? Derivative of cot x?
Minus secant square x.
Okay, minus secant square x. Right. So I don't want derivative. I want to integrate this. Okay. So what should I do? I can write this as cos x upon sin x dx. Right. Now any clue? Any hint? Can you suggest what to do? I have sin x. I have
Sin x. Sin x is the derivative of cos x.
Yeah, sin x is derivative of cos x. Actually, minus sin x would be the derivative of cos x. But see, sin x is in denominator. Okay, and I don't want dt in the denominator. Dt should be in numerator. Okay, so I will substitute sin x equals to t. So its derivative will be cos x. So I will get t in denominator and dt in the numerator. Right? So I will substitute. I will say let sin x equals to t. So its derivative will be cos x, okay, is dt by dx. So cos x dx is equal to dt. And if I substitute that over here, what do I get? I will get integral of dt by t. Right?
Yes, sir.
Okay. So that is
Log t.
log t. Okay, so it is log t. So that is equal to log of t plus c, and that is log of what is t? Sin x plus c. Right?
Yes, sir.
Okay. And which log is this? Log to the base 10, log to the base what? It is always log to the base e. Okay, natural logarithm. Okay. It is always,
Okay, sir.
if it is not given, then it's always log to the base e. Okay. All right. Next question is 2x divided by x square plus 9. Now this is easy. This is exactly similar to the last one. Okay, so here what I should do is I should substitute
T for x square plus 9.
t for x square plus 9. Okay, so let x square plus 9 is equal to t. So its derivative is 2x is equal to dt by dx, and therefore 2x dx is equal to dt. Okay, and then okay, I have got 2x dx. I will substitute that here. So what do I get? It's equal to integral of dt divided by denominator I have t. So what's that? It is
Log T.
log t. So log t plus c. Okay, so that is equal to, what is t? T is x square plus 9. Let's substitute that. So it is log of x square plus 9 plus c. Right, very simple.
Yes, sir.
Yes, sir.
Then what about this? I have x tan of x square plus 9.
Multiply and divided by 2.
Okay, we will multiply and divide by 2. Yeah. So we'll substitute.
Then substitute T for x square plus 9.
Then substitute t for x square plus 9. Okay. So let t equals to x square plus 9. So I get dt equals to what? 2x dx. Right? And what do I have? I have x dx over here, x dx. So I can take this 2 on left hand side. So it goes into the denominator. So it is dt by 2 equals to x dx. And then I will substitute that here. So it is tan of, okay, tan of what? Tan of t dt divided by 2. So I will take 1 by 2 outside. Okay, so I will write this as I equals to, I means integral. Okay, and then I have tan t dt. So I can do its integral in the exact way of cot of t, right? So I can write this as half of integral of sin t over cos t dt, and then I have to do another substitution. Okay, so this time I will put cos t equals to, let's say, what comes after t? P, Q, R, S, let's say P. Okay, so minus sin t dt will be equal to dp. Getting this? Yes or no?
Yes, sir.
Okay, you got till this point? Till this point there is no confusion?
Sir, but
Yes, sir.
can't we substitute directly the value for tan t is equal to secant square t?
Tan t equals to?
Secant square t. Derivative of tan t.
Yeah,
Can't we substitute directly?
but it is derivative, no?
Yes, sir. Yes. Sorry, sir. Sorry.
I want to integrate, right?
Yes, sir.
Right, Veera? So these are getting slightly complicated. Okay, maybe we will not encounter questions like this, most probably in the NEET exam, but in JEE they might be there. Okay, Veera.
Okay.
Are you getting this or not?
Sir?
You got this, or there is some question?
No, no question, sir.
No questions. So I can substitute in place of sin t dt minus dp. Okay, so integral becomes half of minus dp divided by p. So it is minus sign I can take outside. So minus half of log of p plus c. Now I can substitute what is p. So it is minus of half of log of what is p? P is cos of t. Okay, so it is cos of t plus c, and it's equal to minus half of log of cos of what was p, sorry, t, it is x square plus 9. So let's substitute x square plus 9. Okay, plus c. All right.
Yes, sir.
Yes, sir.
Okay, good. So simple, no? Now this one. Tell me.
Substitute t for x square.
Substitute t for x square. Very simple. Okay, so let x square equals to t. So taking derivative, I can write 2x equals to dt by dx. If I take dx on left hand side, so 2x dx equals to dt, and therefore x dx equals to dt upon 2. So that I will substitute here. I have x dx, it is dt upon 2. So it's equal to what? 1 by 2 I will take out. So it is e raised to t dt. And what is its integral?
1 by 2 into e raised to t.
1 by 2 into e raised to t plus c. And now let's substitute t, which is equal to x square. So I get I equals to e raised to x square divided by 2 plus c. Okay, very simple, right?
Yes, sir.
Okay, so yes, so this is till now we have seen integration by substitution. I will teach one more method. Okay, this is 99% of times not required in NEET. Okay, but 1% there is 1% chance, but in JEE this will come very often. Okay, so please pay attention. It's not very difficult. Okay, so let's see. Integration by parts is the second method. So there are lots of techniques of integrations. Okay, integration is a skill, right? So we are seeing only two of them. In substitution we saw some subtypes. Okay, but the general type is substitution only. And next we'll see integration by parts. So see integration by parts. So now let's suppose we have u and v. These are two functions of x. These are functions of x. So I know the product rule of derivatives. What is product rule of derivatives? If I take derivative of this, it will be u dv by dx plus v du by dx. This you know.
Yes, sir.
Okay, we know product rule of derivatives. So it is, if I have two functions and I want to take them their derivative. Okay, if I have multiplication of two functions and I want to take their derivative, then it is first function as it is multiplied by derivative of second function plus second function as it is multiplied by derivative of first function. Okay, this we all know. Then what I will do is I will integrate this. Okay, so I will integrate this equation. What do I get if I integrate this thing? So I will put an integration sign and dx over here. Then everywhere I will put integration sign and dx. So I am taking integration with respect to x. That's the meaning. Okay, so here also I will put integration and dx. Then now what I will do is I will consider this thing, this term. So let's suppose I want to integrate a function which is like this, which is combination of a function and derivative of some other function. That integration I want to take. I have multiplication of one function multiplied by derivative of other function inside the integral sign. Okay, so this is my integrand. Okay, so I will take this thing on the other side. So on this side it has got plus sign, so on the other side it will have minus sign. Okay, so on the other side means on this side it will have minus sign. So I will write this thing first. Okay, so I have written this thing first. Then now here I am taking derivative and then integral. So the derivative and integration gets cancelled out, right? Because integration is antiderivative. Yes or no?
Yes, sir.
Integration is antiderivative. So I am taking derivative of a function, then I am integrating it. So derivative and integration, it gets cancelled out. So I was taking derivative and integration of u and v, u multiplied by v. So I will get u multiplied v back. Okay, so I get u multiplied by v back. So I am writing it here. And then I am taking this term on left hand side. Okay, so by the way, I am writing it on the right hand side. So this term I am writing as it is. It will have now negative sign plus c. Okay, then this thing dv by dx into dx I am writing as dv. Okay, so you can say this is differential of v, right? It is differential of v.
Yes, sir.
And du by dx times dx I am writing as du. Okay, so without going into more details, we can say dx cancelled. Okay, so see what I have got is I want to integrate this thing u dv. Okay, I want to integrate u dv. So I have one function and derivative of some other function. I want to integrate that. So what is its integration? So I got this rule. This is the rule for integration by parts. So I will integrate this second function. Okay, so it is u times v minus I will take integral of, now I will take derivative of the first function and multiplied by integration of second function. Okay, so integration of u dv is equal to u times v minus v du, sorry, integral of v du plus c, because we have done this integral. Got it? A plus c we can write at
Yes,
the
sir.
end. So there is no need to write plus c over here. After solving the integrals, we can write plus c. Okay, so integration of u dv is equal to u times v. So I am integrating this second function. Okay, and then what I will do is minus, I will write integration of, now I had u dv, I will take derivative of this one now. So I will write du times integration of second one, v. So v times du. Okay, inside the integral sign. Okay.
Yes, sir.
Okay, so most of the times in
Yes,
math,
sir.
yeah, good. So in math textbook also, most of the times this book, this formula is just stated. Okay, I have derived it for you so that you will understand it. Anyways, so let's try to solve some problems. So now, while solving the problems for integration by part, there is a rule called ILATE. Are you aware of this?
No, sir.
Okay, so what is this rule? So I said there will be one first function which I will consider as a function, and I will consider second function because I will have multiplication of two functions. So I will consider one of them as derivative of some other function. Okay. So how to prioritize these functions? There is a rule for that, which is known as ILATE. Okay. So what does it mean? What does this mean is I means inverse trig functions. Okay, sine inverse x, then cos inverse x, tan inverse x, etc., etc. Then L means logarithmic function. Okay. A means algebraic function. Okay. Then T means trigonometric functions, and E means exponential. Okay. So I will have multiplication of two functions, C, and I want to integrate this. So what is my U and what is my V? So the rule for that is this thing, ILATE. Okay. So see, this is algebraic function, this is the trigonometric function. So which one comes first in this one? Algebraic, right? So this is my U, and see, trigonometric comes after that. So that will be my V. Okay, so this is not V, this will be dV, right? So let's write U. Okay, before that I will write U equals to X and dV equals to what? Cos X, but cos X can't be dV, right? It will be cos X dx. Okay, that means your dV by dx, if you take dx on the left hand side, you will get dV by dx. dV by dx is cos X, means cos X is, sorry, means what? V is what? You got this. dV by dx is cos X. So what is V? Whose derivative is cos X? Which function's derivative is cos X?
Sin X.
Sin X, right? So V is equal to sin X. Okay. So now, and what will be du? Du by dx will be 1, since u is equal to x. Du by dx is 1, so du will be equal to dx if I take it on other side, right? So okay, so I can write this integral as, tell me, u times v. Okay, this is u, this is u, this is v, dv. So I will write u times v. Okay, so u times v minus integral of what? V du. Okay, so let's write. So I would rewritten the formula. What is u? U is x. What is v? V is, we found it out, it is sin x. Okay, so it is x sin x minus integral of v is sin x. And what is du? So
dx.
du is equal to dx. Now what is integral of sin x dx? It is
Minus cos X.
minus cos x. So minus cos x and this minus sign gets cancelled out. I mean minus minus becomes plus. So we have x sin x plus cos x plus c. Got it?
Yes, sir.
Sure, Veera?
Yes, sir.
Okay. Tell me this one. What is my rule? Who is late? I am late.
ILATE.
ILATE. Okay, so now where is the exponential in this? This is exponential. Okay, so now tell me, what is u?
U
U
is
equals
equal to x
x. So du equals to dx.
dx.
Then dv equals to e raised to 5x dx, or I can write dx on the other side. So dv by dx equals to e raised to 5x, right? E raised to 5x. So this total is dv. Okay, and therefore what do I get? What will be v?
V is equal to e power 5x by 5.
E to the power 5x by 5. Okay, good, because if I take its derivative, it will be 5 e raised to 5x, and that 5 and this 5 will get cancelled out. So this is v. Therefore v is equal to this. And now we can solve this. So let's write I equals to u times v minus integral of v du. So which is u times v. U is x and v is this thing. So it is x multiplied by e raised to 5x divided by 5 minus v times. So what is v? V is this e raised to 5x by 5. So v e raised to 5x divided by 5 multiplied by dx. So what is this? It will be e raised to 5x divided by 5 again. Okay. So is it getting complicated?
No, sir. Clear, sir.
Okay. So e raised to 5x divided by 25. So yes. Next one, log x dx. Now again, so where is the log? Second one. So this is my u. Okay, and algebraic is v. So this is equal to, we can write, or let's write u equals to log x and dv equals to dx. So therefore du by dx is 1 upon x. Okay, and du equals to 1 upon x dx. Du equals to 1 upon x dx, and then yeah, dv equals to dx. That means what is v?
V is equal to x.
V is equal to x, because dv by dx will be 1. Okay, derivative of x is equal to 1, so v is equal to x. So therefore v equals to 1, sorry, x. Okay, so therefore I is equal to integral, sorry, u times v minus integral of v du. So what is u? It's log x. What is v? It's x. X log x. We have minus integral of, what is v? X. And what is du?
X.
Du is 1 upon x dx. Okay. So x gets cancelled out. It is integral of dx only, which is x. So we have x log x minus x plus c. Okay. Simple.
Okay, sir.
Now
Yes, sir.
imagine what would have happened if we had taken, let's say, this equal to u and this equal to v. Okay, so it would have been a disaster, because see, you have, let's say, if you take this as what u and this as v, so you have integral of v du. Okay, so that log x will keep on appearing, it will not go away, right?
Yes, sir.
We don't know how to integrate it without doing this, right? So yes, then let's solve this. Okay, so this one will do similarly. Again, this is exactly similar to the last one. Okay, so
U is equal to log x.
u equals to log x. Therefore, du equals to 1 upon x dx, and v is equal to, sorry, dv equals to x raised to n dx. I forgot writing dx over here. Okay, so dv by dx is x raised to n. That means v is equal to x raised to n plus 1 upon n plus 1.
Yes, sir.
Okay, so we can substitute that over here. What do we get? So I equals to u times v minus integral of v du, and that is, what is u? Log x. What is v? X raised to n plus 1 divided by n plus 1 times log x minus integral of, I have x raised to n plus 1 upon n plus 1 multiplied by 1 upon x dx, right? Okay, and this x
Okay, sir.
will get cancelled with one of the x in this x raised to n plus 1. So I will be left with x raised to n. So this is equal to x raised to n plus 1 divided by n plus 1 log x minus, I will have 1 upon n plus
X
1 I can
power
take.
n plus 1.
Yeah, so it will be x raised to n, integration of that will be x raised to n
X
plus
power
1
n plus 1 by n plus 1.
n plus 1. Okay, plus c, right? So this is simple.
Yes, sir.
Okay, and this one,
U is equal to sine inverse x.
u is equal to sine inverse x. Good. And v equals to x.
Dx.
Yeah, that is dv, no?
Yes, yes, yes.
U is equal to sine inverse x. What is du by dx then? 1 upon square root of 1 minus x square. Okay,
Okay, sir.
and dv equals to dx. That means dv by dx is 1, so v is equal to x. Then integral I is u dot v minus, sorry, integral of v du, and this is equal to, u is sine inverse x, v is what? X. So x sine inverse x minus integral of v is what? X divided by square root of 1 minus x square dx. Okay, yes. Now what to do? What to do now? Substitute this thing equals to t, right? Let's substitute 1 minus, sorry, 1 minus x square equals to t. So minus 2x dx equals to dt. Okay, and I have x dx over here. Okay, so x dx minus x dx equals to dt by 2. So we can put it over here. So what do I get? I get I equals to x sine inverse x as it is minus 1 by 2 dt by square root of t. Yes, no?
Yes, sir. Yes, sir.
Okay, so it is 1 upon square root of t. That means it is t raised to minus half. Okay,
Yes.
it is 1 upon t raised to half. So if you take it in numerator, it is t raised to minus half. Or let me write it, x sine inverse of x minus I have half, and it is integral of t raised to minus half dt, which will be t raised to plus half divided by half. So it is x sine inverse of x. Okay, so t raised to n plus 1 upon n plus 1. What is n? Minus half. Minus half plus 1 is plus half. Okay, so I have t raised to half upon half plus c, and I have this half in the multiplication. So this half and this half gets cancelled out. So it is t raised to half only, and I will write that over here. Okay, so the integration I is equal to x sine inverse x minus t raised to half means its square root of t,
root 2.
1 minus x square. Okay, plus c, right?
Yes,
Oh
sir.
no, wrong. See, this negative sign I forgot. So minus x dx is dt, right? So I had minus x dx equals to dt. So this should be plus everywhere, and here also plus. Now it's right. Okay,